What's up, everybody? Welcome to Flux Harmonic. I'm David Wilson, and today we're back with another live stream where we try to create something cool from scratch. And this week we're continuing our work on the game that we started a couple weeks ago, which is basically like a hacker-styled mahjong game. And today our goal will be to create 5 to 10 basic tile face sprites for the game board and then get them displaying on the screen or on the game board in a randomized way. So if you've ever seen mahjong before, you just have a screen full of tiles that you're supposed to be matching every 2 tiles that you see that have the same face. So we're just going to try to create some basic faces today for that purpose. So as far as updates are concerned since last time, I've made a lot of progress improving mesh build, which is what we were doing on the stream on Tuesday. But I'm not really ready to show that yet, mainly because I've sort of redesigned a couple of things and it's not fully working, but I'm almost there. I think if I have like 2 more days over the weekend, definitely it'll be done. So by Tuesday, I'll have like the full mesh build working and potentially even getting to the point where we can start producing game builds that get automatically deployed, which would be cool for you guys to be able to try what I'm doing as we make more progress in the game functionality next week. Also, I spent a little time polishing up the tile rendering that we already wrote for Crash the Stack since the last time we worked on it, which I think was last Thursday. Mainly because there were just a couple little things I didn't like about it. It didn't look exactly like what I had before. So I got that working again, and we'll take a look at that in just a moment. Hello to Luis and Daigo. Thanks very much for being here. Appreciate it. All right, so let's talk about what we're going to do today. I've pretty much already said it, but we're going to say it again. The idea is that we're going to do a little bit of poor man's game graphics because I'm not an artist. I mean, I have sort of, I guess you could say visual taste in the sense that I know what I like, but as far as, the mechanics of making art, I'm not so good at it. But I'm going to try to make some basic art today for this game just as a way to have something to include in the playability or the game logic of the game, because it's going to be pretty boring if I just have numbers on tiles like I had in the past. This time we're going to have something that's a little bit more like shapes, but it's going to be very crude. So the other thing is that we're not following traditional mahjong in terms of what tiles exist in those games. There's a lot of Chinese letters on the tiles, or pictograms or like flowers and stuff like that. So since we're going with a more hacker focused theme, we're going to use some different types of shapes. And today it's going to be very, very simple things like circles and rectangles and triangles. But eventually, as I get a little bit more ambitious with my art skills, or maybe if someone takes pity on me and decides to try to help with the art aspect of things, we will have better looking art that falls a little bit more in line with the hacking aesthetic of the game. So after we get the basic tile faces sketched out using the GIMP, which I forgot to mention before, we're going to write up the code necessary to display these tile faces randomly on the simple game board that we crafted last week. So it's a very, very simple board. But the idea is that since we've already got the ability to describe tiles, all we need now is just a way to say what face goes on which tile and to actually try to generate a board that is conceivably playable, but we don't really have logic to check whether it's playable yet. And if we have time, we may actually start trying to write the code that decides whether a given board is playable, basically by checking all the tile positions and seeing if there's at least one tile position that's playable. We may not be able to tell if the entire board is playable because that's like a tree of possibilities, but at least if we can get one movement in the beginning, that might be good enough. So perhaps by next week we'll have a basic playable build of the game, and if we have everything set up with mesh build, so I can automatically build at least a binary for maybe Linux, and if we're lucky, Windows, then you all might be able to play what we were working on as I'm adding features to it, which would be pretty cool. So as I mentioned, the tasks are to drop some basic tile sprites in the GIMP, then to try to write some code to display those tiles randomly on the board, and then maybe start writing the code necessary to check whether tiles are playable or not. I'm gonna bet that we're gonna have another task in here that I forgot to write down, which is update the texture renderer to support sprite sheets. And I mean sprite sheet in the most basic way possible. If you don't know what a sprite sheet is, basically, hey Jackson, nice to see you from Twitch this time. A sprite sheet is a single image that contains multiple sprites or game graphic images that share the same texture. So if you have like one character in your game that you're trying to animate, typically what you would do is have one image that has multiple frames of that character's animation in the image, because it saves you from having to load 10 images whenever you can just load one image and then use math to figure out which part of that texture that you will display for the character for a given frame. So we're not going to write the full logic for calculating those positions based on a tile or a sprite index yet. We're just going to do basic texture coordinates, but a little bit later we'll write the other code necessary for doing real sprite rendering with animation frames. That will actually come into play for tiles too, because I want to have these tile faces be a little bit animated based on what type of tile they are. So that could be pretty cool as a little visual, sprinkling a little visual sugar a little bit later. So yeah, let's go ahead and get started. Let me first show you what I did since last time in improving the way that the tile rendering looks. So right now you can see that we have the little stack of tiles that we started with last time. Now it's actually lined up very nicely where all the tiles line up together. They seem to be meshed together. You can see, it's kind of hard to tell because it's not zoomed in as much, but you can see that there's a little bit of a line between the tiles that gives it that sense of depth. And they have the nice stacking effect. So what this really took was me remembering how I had done it the last time. I sort of factored in the fact that there are these little sort of side pieces of the tile where I need to adjust the position based on where those end up. So whenever you do the right math to place these tiles on screen and render them in the right order so they overlap correctly, then you get a nice looking effect. But we didn't have that the last time because I forgot what I had done. So at least we have that as a starting point, and the goal is that all of these tiles should have a different icon on them by the end of the stream if we manage to make good enough progress for that. So the actual solution for that was, instead of using the entire texture width for, let me turn on scheme mode here. Instead of using the entire texture width for the tile sprite as we had been doing before, which is like a 33 pixel wide image, we're gonna be using 30 instead. So we're like shaving 3 pixels off there. And that was enough to get everything to close the gaps and render correctly. Same thing for the height. I think it was like a 39 pixel or 38 pixel, and now it's 36. So we're hard coding that a little bit, which is not great, but it's early days and we'll fix a lot of that later. Let me check on the stream health. Things seems pretty good so far. I think my internet issues from last time shouldn't come into effect this time. So let me know if you run into any buffering or anything going wrong with the stream, and I'll see if I can do something about it. So that's pretty much it. We'll go ahead and switch over to GIMP instead. I don't know if you know, but GitHub seems to be having a little bit of an outage today, which is kind of funny. Daigo has put a Mahjong tile into the chat. Thank you very much. We're going to run the GIMP. I hope... Oh, do I not have it installed? Well, that shows how prepared I am today. All right, let's go into vterm, and we'll just install it into the main profile. Come on, eeks install GIMP. I think it should be good enough. Hopefully it doesn't take long. While that's installing, unfortunately, I don't have an example of what the updates to mesh build look like from what I did last time, but it looks a lot more declarative now. It's using more of a functional style with how you describe the various steps of the build, and it sort of hides parameter passing behind function closures. So whenever we get to actually looking at that implementation, I'll explain more about what that means, but it's pretty cool. I mean, it's a pretty decent design, I think. I'm not going to toot my own horn or anything, but I think it's pretty cool so far. All right, GNU image manipulation program. Maybe it was there already and I just typed the wrong thing. Okay, so let's first of all open up that tile image. I just want to take a look at it real quick. Man, that's tiny. Let's go up to 400, 800. That's still not even good enough. Is there like a higher level of zoom? Whatever, we can make do with that. So can I split this window? Single window mode. Windows. I don't use GIMP a whole lot. That's fine. So what I'll do, I think this, like I said before, this tile surface is, come on, I gotta grab the right position here. 30 by 35 is what it is. Okay. So what we need is an image that is a multiple of that. And the goal is something like 5 to 10 tiles. So if we were to do a little bit of math here in the eval prompt, if I want, let's see, 2 rows of 5 times 30, so 5 times 30 is 150 by, and what was it, 35? Is that what I said it was? 35, yeah. So 2 times 35, so it's 150 by 70, is that right? We'll find out. 150 by 70 pixels, that's a tiny image. Okay, so then we're gonna zoom this one also into about 800. Maybe I will try to draw in like a little bit of a guide. Maybe I'll put another layer for that. New layer. And did I make the background transparent? Let's see. Add alpha channel. And then can I like select all and delete? Okay, cool. I probably will need that. But also, I'm going to add another layer as just like sort of a background color. It's not something I want to have in the image itself, but it'll be helpful to understand what we're looking at a little bit. Okay, so let me just drop in. I don't really want to be looking at white the whole time, so let me put in like a light gray potentially. This could be a terrible idea, but we'll find out. Okay, so can I get a 1 pixel paintbrush? Size 1. And let me throw, that's the wrong layer to put that on. Let's put black to start with, just to see. Oh, okay, so this is, needs to be, can I change the brush? Yeah, there we go. I think that's the one I want, pixel brush. Ah, that's not right. Still has a size of 3. Come on, dude. Dynamics off. I had a way to do this in the past. As you can see, it's been a while since I actually did any pixel art in GIMP. There are better programs for this, but they're not quite as easy to install in GIMP, like a Sprite. Okay, so let's just look this up in the browser maybe. GIMP, how to draw pixel art. Terrible question. How to set up GIMP for pixel art. We're not watching any videos right now. DeviantArt, pencil tool and eraser. Don't use tools such as the brush tool. Yeah, no kidding. Only use the pencil tool. So am I using the wrong tool? Is that what's happening? Oh, let's do this. That's where we are. Okay, so pencil. Cool. Much better. All right. I wish I could zoom in more. So how about GIMP zoom past 800? If I could zoom to like maybe 1,000 or 1,200. Edda says, did you take a look at Krita? Is Krita more for like digital painting? I don't know if it's appropriate for this. Image reading through tools, zoom. Hey, Edis. All right, so, whoops. Let's click on GIMP here. That's not what I wanted, but that's fine, I guess. Tools, zoom. Can I zoom more? Hey, there we go. Great. Oh, you know, probably if I'm not stupid, I could just realize I can type any number I want in this box. Okay. We'll get the little process figured out here. I mean, ultimately my goal would be to do all the art for this game myself, and I'm not an artist, like I said, so we'll have to see whether I can do a decent job of it. So maybe, can we draw some lines? Maybe I can draw some lines. Looking for the right tool for this job. GIMP draw lines. What I want to do is try to draw the lines for the tiles and maybe see if we can get a sense for how they look on the tile images. Maybe we can sort of do this piece at a time. All right, shift key, is that what it is? Can I do that? Click, shift, oh, okay. All right, fine, good. Cool. So 35, right? I think we're splitting this basically in half. So that's 35. All right. And then 30. Just drawing a little bit of a grid here to have our bearings. So 60 would be the next one. And then 90. Whoops. All right, right there. And then what would it be? 120? 120 right here. Okay, so let's just, finish this off. That gives us a bit better of an impression of what we're doing. In fact, we don't want to keep this grid all the time. So what I might do is make that a separate layer. So let's take that layer. Okay, so that's another layer. That's our grid layer. Let's rename that. Where is the rename? I think if I just click on it. Okay, grid. Backdrop. Okay. Cool. So now let's try to draw some stuff just as a bit of fun. I'm going to save this first just so we don't lose anything, because that would be really annoying if we happen to lose what we have done so far. Projects, code, crash the stack, assets, images. We'll call it, where is the file name? Is it up here? Call it faces.xcf. Okay, so really basic, stupid stuff. What we will do is start with some colors. Let's just get some basic color going on here. Maybe pick something a little bit more interesting than just plain old flat red. So let's start with that. So what we could do is start with, let me do I want to do like a rectangle. Oh, yeah. I know how to do that. I just need to use a selection tool. So GIMP does give you some nice abilities to draw things, but you just have to sort of think in GIMP terms. All right, so that seems relatively centered. Maybe that's better. All right, so we'll start with just like a flat red. Oh, come on. I had a selection just ready, waiting. Select, undo, rectangle select, undo, man. Maybe go back and put another layer in. I forgot about that. So we'll put this below the grid. Okay, so it was selected, it just wasn't visible. That's fun. All right, so that's just a plain square, okay? Pretty boring, nothing special. We're just gonna draw that there for now and see how we feel about it. Ellipse select, we can draw a little circle here as well. Okay, maybe we'll make that one blue. Man, how did this dialogue get so jacked up? Part of the fun of using EXWM is that things like the GIMP do not want to cooperate. All right, so now I'm gonna put that in. That's, maybe I want that to be a little bit less feathered. So if I go into the settings here, bucket filled, no anti-aliasing. Okay, let's take that off. Is that good? If I take the backdrop off, it's probably easier to see against white. Or maybe the contrast isn't so good. No threshold. Let me try this again. Undo bucket fill. Okay, that's marginally better. Still similar colors. Ah, you know what? I bet the selection itself has feathering on too. Anti-aliasing. Okay, so undo bucket fill. Fill it again. Oh, what just happened? Undo ellipse select. Okay, well, that's good enough for now. We'll take a look. So now we can do like maybe a green triangle. How about that? So what I can do is grab a greenish color here. Let me make sure I can see the bottom where it shows me the preview. Yeah, that's probably good. And then I'll get the pencil tool again, start about right here, and just do a really bad job at drawing a triangle. What happened? Didn't draw anything. Why does it think it's gray? Oh, I know why. It's because there's still a selection. None. Select none. Okay. My mistake. Okay, so right about there. Ooh. Jaggy. Oops. I'm doing this with a touchpad, which is like the worst idea in the world. But that's what I have right now. I don't have a mouse. I wish it would give me a little preview of the line as I'm drawing it, because I can't tell what the ideal angle is to get the line to not be jaggy. Okay. That's a little unfortunate, but whatever. Terrible. Better. Okay. So now I can just fill that. All right. A little bit wider than I wanted, but maybe I can just chop some things off. How about this? I'm going to do a little rectangle select here. Maybe I'll just chop a little bit off that. Could give it a more of a interesting look. Sometimes you just got to roll with it. Okay. So that's good enough for 3 tiles. So maybe what I'll do is take off the grid and the layer and then export. Faces.png. Fine. And then we will, let's see, what format do I want? I think I want 8-bit RGB, because I think that's what we needed the last time. Hopefully the colors that I use are going to come through on that. We're going to find out real soon. Hackers and painters, I like it, Daigo says. Yeah, well, you know, this is what we're going to try to do on this channel, is do a little bit more creative stuff and see how well it goes. Assets, faces. Okay, so it seems to be there. Now we're going to see if we can draw something with it. And this is where it's going to get a little bit more interesting. Okay. So let's get back into the main code. Let's get rid of that window there. So for tiles, what we might want to have here is a face. And it's maybe going to be an index. And then we also need to load the faces sprite. Or I guess you could call it the faces texture. And then we'll just use faces here. All right. And then if we want to draw that somewhere, we have the face index. And maybe if we go here into the tiles we were already creating by hand, we can just say face 1. And just drop those in a bunch of times. Just to make sure that it shows something. Oh, maybe 1 is not the right one, but that's fine. Let's just go with that for now. Let's do this. Make it a little bit more fast. Query replace layer with face 1 layer. Yes, 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 yes. Okay, that's done. So now if we know what the face is, we can go to our tile rendering code. And let's see. We have the... So we may need to start saving some intermediate values on these things. When center X. I don't have a let star function in mesh right now, so we may have to do another let binding inside for now, which is a little bit unfortunate, but it's not terrible. So if we do, let's say, tile X, wind center X. Okay, so something like that. Then based on that tile X, we should be able to render, or tile X and tile Y, we should be able to render the face as well. In theory. We're going to find out whether that theory holds true. So draw texture, tile X, tile Y. That should be enough to keep things going. Let's just, run the code really quickly to see whether we've broken anything. Okay, I think I did a bad job with the let somewhere. Yes, I did not enclose that. I need to add a good error for that because otherwise it's impossible to tell that you've not put the body of the let in. Okay, so there's a crash. Okay, error decoding PNG file data buffer too small. Let me check what the, can I tell what the file is here? Image properties. This is it. RGB color, PNG image. What am I missing? 8-bit gamma integer. Let me open this file then, see what it says too. I want to overwrite tile 2. Open faces, and then image properties. Seems to be the same. Color profile, sRGB. Yeah, I had an issue with this one time before. Oh, doesn't seem like it has an alpha channel, does it? Maybe that was a mistake. Okay, let me try to export this one more time. Export as. Export. Yes. Save color values from transparent pixels. Oh, RGBA. Okay, I missed that part. That's probably why it's not working, because I'm saving things as RGBA. Or loading them as RGBA. Save color values from transparent pixels. I don't think we need that. Here, let's try this. And run it again. All right, this time it seems to be happy. Okay, so we're not drawing anything yet, obviously, but we're going to start drawing it now. So we've got render draw texture for one thing. Let's do render draw texture here as well. Now, this is a place where we need to decide how we want to constrain the part of the texture that's being drawn based on which face that we're looking at. So ideally, what we could say is that there's a text X, text Y, and then a width and a height. So we need some extra parameters. Let's see what. I'm trying to think of like how I want to name this function. Let's go into graphics. Okay, I don't have it. Whoop. Graphics. No. Source substratic. Source graphics. Oh, it's renderer now. I forgot. So we have draw texture. Draw texture EX. Okay. I'm going to call it draw texture region, I think. That seems reasonable. So we will copy this function and we'll make a new one, draw texture region. And we need to know, like I said before, the X position, Y position. We need to know the width and the height of what to be drawn, and also the texture X and texture Y position. So yeah, I think we're good with that. That's probably all the information we need. And maybe width. I'm trying to think of whether width and height should be before or after the texture parameters. Let's go with it this way, and then we'll change it later. Okay, so back in render.c, we'll also take width and height. And that's going to be 4 and 5. And then scale, well, we probably still want those. So we're going to also add texture X and texture Y. And these are probably not the best names for these, but I'm just going to stick with this for now. And then this is going to be 8 and 9. So draw texture EX. Let's say draw texture region EX also, because we do want to pass along draw args. And when we pass these things in, we're also going to pass in width, height, texture X, texture. I can't type today. Texture Y. All right, good. I'm glad the formatter prettied that up a little bit. Okay, so now draw texture. Well, draw texture EX is really the one we want to copy here. Now I'm probably gonna have to reuse some code here and not just blast out the same thing over again. So we'll see what we can do here. I'm gonna jump down after this definition. I'll add in draw texture region. And then we'll add our extra parameters that we needed to have here, which would be, there are floats here, which is fun. Float width, float height, float texture X, float texture Y. Okay, let's save that. Let's get it a little bit reformatted there. If I drop this, is that gonna make the code formatter redo it? Yeah, fine, whatever. Okay, so inside the body of this function, we have texture chords right here. Now, this is interesting because previously we were able to use hard-coded texture coordinates, but now we can't, because they're going to be different for everything being drawn. And that has an implication on how we store this information, because this is stored in GPU memory using a vertex buffer. Let me check my shader. Shader.c, I think. So texture coordinates comes from text O, which is a uniform. And then color. Text cores is coming previously from the fragment shader. No, this is the vertex shader, then passed on to the fragment shader. So, in theory, we could actually have a uniform for the texture coordinates as well that gets passed through. Let's see. In the code for renderer, where does that stuff get bound? I want to see. Draw texture. All right. Let's go down to the next one that we were working in. Maybe I'll split the screen a little bit. So we have our. Let me move this slightly. Nah, that's horrible. Never mind. Uniform? Yeah. Get uniform location, shader program, projection, view, model, color. Okay, so I could, in theory, add texture coordinates as another uniform. Though I wonder what the performance implication is of this. I mean, if you're just setting it every single time, then it sort of defeats the purpose. And honestly, if I'm setting it every single time, then really what's the purpose of even encoding vectors? I mean, sorry, texture coordinates here in the vertices. Yeah, it's not so easy, I think. This may be the first time I have to try to update vertex buffer, which I'm not really excited to do, to be honest. So if I were to... see, I wonder what I could do to pass in texture coordinates. If I could put in the X and Y and width and height as like a vec4, maybe. That could be good enough. So how about I try uniform vec4. In fact, let me double check that. So I don't know what I just did. GLSL vec4 or vec4 book of shaders. Okay. Let me get rid of this window here. Okay, so we can actually do a vec4, which is good. And if a vec4 isn't specified, in theory, we could do a default, which would be interesting, I think, to not have to pass in that information at all. But I'm starting to wonder whether it's a performance problem to do that compared to doing real vertex buffers. Maybe I should just do vertex buffers for all sprites, where they just have their own vertex buffer. But even then, you still have to update the texture chords. All right. I think I've convinced myself that this is probably worth doing for the short term. I don't need this anymore, I think, if I do that. So I can just say vec4 text chords. And then texture text O, text chords. Now, I wonder what text chords is in this case. So it was a vec2 before, which is kind of weird. Why would it be a vec2? Text UV. In vec text UV. Oh, okay, so there's already... Ah. There's something here already for that? Hey, Fikri. Okay, so location 1 is position. Location 2 is text UV. Let me see what I was doing in my... What is it? Render.c. Enable vertex attribute array 0, 1. Rect element buffer. Yeah, okay. Yep, that's fine. So down here, I don't think we were ever setting that. There's text 0. I think I have some stuff in here. I don't know why I even have this part in here, because we're not setting it at all. Yeah. It's kind of bogus. Okay, so OpenGL pass texture coordinates into shader. Let's take a look at this. Textures, pass 3 texture coordinates. Oh, hold on. I'm sorry, that's probably... Yes, that's what's coming from the vertex buffer. So I think it's this part. These two things right here. So for each vertex... Okay, I see now. All right, let me think about this for a second then. Okay. OpenGL update vertex buffer. I don't even know if this is a best practice or not. It might be a bad thing to do. Buffer sub data. Yeah, I don't want to reallocate. Subdata is only if you want to replace. Man, this white background is not doing very well for my eyes right now. Vertex attributes, array buffer. I think that's what I have right now. I have an array buffer. Yep. All right, so I have an array buffer and I have an element array buffer. Now, all I really need to do is set the texture chords. Everything else is fine. Now, I could tweak the positions at some point in the future, but let's just look at the texture chords at the moment. So the way we set this up is I'm reusing the same rectangle. Yeah, it really starts to beg the question, should I reuse a vertex buffer, or should I have them per sprite potentially? Or class of sprite, I suppose. Well, we'll go with this approach for now. So if we want to use GL buffer sub data, what are the parameters? Target offset size. Yeah, so that's what we would end up having to do. GL buffer data. Size of vertices, GL static draw. GL static draw, it's not part of this, okay. So sub data would allow us to target the texture coordinate data. Let me go back and change that shader back, because what I was adding there doesn't make any sense. So let's do that part, take that part out. Okay, so we're back to where we were. Okay. GL enum target. Bind vertex array. So we bound the vertex array. Probably want to set the texture position stuff later. I wonder if we should pre-calculate a little bit. So we have all that we need here. What we need is calculate the texture coordinates. So for texture coordinates, we needed to use the width and the texture x and or width and height and texture x and y. So I think it's like if you have a position 20 out of a 30 pixel wide image, 20.0, then it would be 0.6. So you put the x position, so let's say texture x divided by width. This could be float ux, then uv. Is that right? No. tu, tv, I don't know. Texture u, texture v. How about that? U and v are like the texture space coordinates, I think. All right, so this needs to be height and y. So if texture x is the width of the image, then it's going to be 1. And then same for the y axis. If it's the height of the image, is going to end up being 1. Otherwise, it's going to be 0 to 1. And that's the texture coordinate system in OpenGL, or coordinate space, I guess you could say. So that will give us the position. We still need the oh, okay, that's not right. So we need to do this too. This is part of the texture width. All right, so that's what we need. Texture width, texture height. And then float region width equals width divided by texture width. And then same thing for region height. And this is going to give us the other part. Well, actually, we need to do this, I think. Texture u plus, to get the right coordinate parts, texture v plus. I don't know if we need to do groupings here, but I'm going to do it anyway. Height. And then texture height. Okay, so region width, region height. Or that's not actually width and height. That's because it has this added into it. So we'll change this for now. Okay. So then at this point, we have our vertices. We could start off like this, or we could just update them every time. Maybe it's better to bake it in. And let's just leave it the way it is, and then we'll change it after the fact. So then we'll make it more efficient later, because I just want to get it working first. Okay, so update the texture coordinates in the vertex buffer. So I think we have our own function, our own vertex buffer here. It's a static variable inside this function. So maybe we'll leave these two implementations separate for now. And so that textures without regions don't get affected, or texture renders without regions don't get affected. So if we want to use GL buffer sub data, let's see how that's different than GL buffer data, what the parameters are. So we start off with the target. Okay, same thing, target. So for this, buffer data is array buffer. So let me go and grab, let's just grab all of it here. Okay, and I'll put this right here. So for each of the 4 vertices, I think I'm going to have to update the texture coordinates. So the size of, we're going to have to figure out the right calculation for this to make it work correctly. So we have our data, we have the size, but we need an offset also, I think, because we're trying to set something inside of the vertex buffer. We're not setting the whole thing again. So let's see. GL buffer sub data set range. I don't know. Advanced data. Hi, Nikhil. Okay, sub data. It's instead of filling the entire buffer with one function call, we can fill specific regions of the buffer by calling GL buffer sub data. Expects a buffer target and offset, the size of the data, and the actual data. Okay, the buffer target and an offset. Where's the offset? Oh, interesting. What is this GL static draw? Maybe that's the difference. Okay, so usage. That can't be right. Oh, offset to start with. So I don't know why size of vertices is here. Interesting. Why would you want to do that? Buffer. Oh wait, that's named. I don't want named. Offset. The offset into the buffer object's data store where data replacement will begin, measured in bytes. So the thing I'm a little confused about at the moment is why my previous code, which admittedly was sort of a little bit copied, uses size of vertices here to move past. I would imagine that should be 0. But the fact that it works is a little bit interesting. So then size specifies a size in bytes of the data store region being replaced. That's not a size. How is this even working? This is OpenGL 4. Okay, different parameters. Size, data, fine. Okay, so there's still 4 parameters, but they have different purposes. So the first one is size. The second one, okay, is offset size. Fine. Fine. All right, so for size, we're going to skip over 2 floats. So what we need to do here for the subdata is size of float times 2. And that's only to set the first vertex. It's going to be the top right one. So this is going to be... Can I do this inline? Probably not. Okay, so float, or maybe even, let's say, vec2. Can I do that? Text uv equals... How are we setting... Whoops. How are we setting those up? Vec2, vec3. Okay, that's how it was. Now I see. Cool. So in fact, I think I can do that right here. Whoa, I can do it right in line because CGLM makes that a little bit easier. Vec2, texture U plus region width. And then texture V plus region height. I hope this works. All right, so let me get rid of that one. I think I need to put this in parentheses. All right, so that should be better now. Okay, so that's going to be for the top right location, which corresponds to what we have here. So let me just copy this really quick so I have a visual read on it while I'm trying to add these. This is ugly, but we'll fix it up after we figure things out a little bit better. So 4, we want to skip 6 items now. Because 1, 2, 3, 4, 5, 6, and then boom, at this next one. And then every time we're going to add 4, I think. So now this is going to be bottom right. Top right would be... Oh, you know what? I think that's wrong. Top right. And it's 1, 1. Okay. No, that doesn't make sense. It's upside down. As far as I understand. Okay, we're going to try it anyway. We're going to see what happens. So we'll try to follow what's going on there. So if it's top right and if that's 1, 1, then if bottom right, we're going to say get rid of the region height here. Then we're also... Static draw need to be there? No. Ooh. Target offset size. Okay, yeah, I missed that part. Size of float times 2. Okay, so we need that, we need that, we need that. This is also going to be 10. 2, 4, 6, 8, 10. All right. And that is bottom left, so we're going to take out the region width. And this is going to be, you know, I could, well, I can't just copy the stuff straight in because there's gaps. So unfortunately, I have to do it this way. And this seems really inefficient to me, unfortunately. But I guess if you had all the position data at the time, you could update the positions and the texture coordinates at the same time with just one little strip, and that might be faster. You could probably just update all of it too, but yeah. Less calls is better, I think. All right, so we're gonna add another 4 here, and then the last one is gonna add the region height back in. Okay, height. So I think that should be it. Yep. All right, so that looks fine, and everything else will basically be the same in terms of what we had written before. So now we just need to try this out. It's probably going to look horrible, but we'll see what happens. One thing we didn't do yet, though, which is basically what I said before that we would avoid doing, and I walked myself right into this problem, is that we're using an index to calculate the face. So maybe at first, let's just hard code the texture position. So the width would be 30. The height would be 35. And in fact, I think that if I were to go look at that, oh, tile height 36. Interesting. It's not what I calculated. But it probably makes sense. Let's just go with the hard-coded value for now. So let's go back here. And then texture X, texture Y. Why not just say 0, 0, and we'll see whether this does the right thing. We may have to experiment slightly. So first we're drawing the texture for the tile, and then we're drawing the texture for the face on top of it. So draw texture region. We definitely want to update the name for this. Renderer, tile sprite, tile X, tile Y, width, height, and then the texture coordinates. So now I need to go into, let's see, renderer.c. Let's go find the module for renderer. And we're going to copy this scheme mode. We're going to copy this. Then renderer draw texture region. And we're also going to add the extra parameters that we need. So width, height, texture X, texture Y. And then we're going to do the same thing here just to pass all those parameters along. Let's clean these up a little bit now. Okay, that's better. Texture X, texture Y. Okay. Clean that up a little bit too. Oh, I need the width and height. Okay. So now I have the functions defined. I need to go back into renderer and add a registration for this draw texture region function. So let me go do that too. I'll copy this line. Draw texture region internal. Draw texture region MSC. Let's make sure that that one is actually calling the right thing. XY with height, texture X, texture Y, draw args. 6, 7, 8, 9. Okay, so far that looks good. So let's try it. It's probably going to crash, but we'll see what happens. All right, so draw texture region MSC undeclared. Okay, that makes sense. I've sort of changed my strategy for how I do this. So maybe what I'll do is I'll move this to the bottom so that that function is defined at the time that it's referenced. And what else is a problem here? GL, too many arguments to function GL buffer subdata. What? Okay, let's find that out. Probably I need to delete that last one. GL buffer sub data. Okay, yeah, the GL static draw thing is bogus. So let's get rid of that. Code formatter will clean this up a little bit. Okay. Maybe not. Fine. Whew, what just happened? Well, I mean, I kind of like it, but it's definitely not right. Oh, you know what? I think I made a mistake in main.msc. I'm telling it tile sprite, but what I really want is the face's texture. Tile sprite. Yep. So I think this is wrong. Face's texture. So it did something before. Whoa. Okay. So we're getting something drawing, which is a good sign to start with, but it's very wrong. Let me think about why this is the case. We're scaling up. I wonder if that's really the problem. Okay, so we may just have to go ahead and do what I had already thought would be necessary, which is simplify the render function by updating all of the coordinates. I may have to turn off centering for now too. So, yeah, that's unfortunate. It is possible to just allocate this and not set all the vertices, and I can just set them all in one shot, which would be kind of nice. Or I could just calculate it all and set it in one shot every frame. Still not great, though. I don't like having to do it this way. But if you think about it, I think it's more performant than what we were doing previously, or what the world was doing previously with OpenGL, where basically you call all of the OpenGL rendering functions, and you incur the cost of function calls for every single vertex and texture coordinate just to set this up. So maybe it is better. So okay, I'm convincing myself maybe this is the right time to experiment with this a little bit. So it told me in this documentation that if I give null for data, or null if no data is to be copied. So what I want is not to copy vertices yet. I want to create a vertex buffer. Oof, goodness, that was super loud. Okay, so we'll say null here. And then we will also copy this part. Thank you to Wemu for following. Hello. Okay. So if I go down here instead and move this over slightly, then I can change how things work a little bit. So what I do know is that I have, yeah, that's probably what the problem is. But think about it. I'm multiplying by the wrong size. Before I do this, I think I might be able to solve this a simpler way. Did I change it back? Nope, 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 nope. Okay. So I'm using the wrong width and height right here. So if I change this to delete that part, that could solve the problem. Scale it as the last thing we do. Texture width times scale. Yeah, let's just take that out and that out. This may not help anything, but we're just trying it out, see what happens. Still huge. Why would it be huge like that? There are definitely some assumptions that I've been making that don't really fit here. Mimu says, I'm thinking of speed running coding courses. Well, sure. I mean, I guess it really depends on what your goals are there. This is game development. Okay, so let's see. The basic assumptions of this function are wrong now, I think. Scale X, scale Y. Maybe we should just get that out of here. Let's try removing the scale part first. I don't think it's going to help. Yeah, didn't help. No, actually, we do need to scale it at some point. Width times scale X, width, height times scale Y. Yeah, so I think that the part of the problem is texture coordinates. Shouldn't matter. Width. Yeah. Let me make sure that all of my calculations so far have been correct on the original part of the code. So tile X, tile Y, tile layer offset X plus wind center times tile X and width. Okay, so that should be an XY position, which we're using successfully before this to render it. Oh, I'm not setting scale, am I? Oh, I am setting scale. Okay. Scaling it up a lot compared to what I would expect. Scale. Scale X, scale Y. Okay. Hello, Soviet Bill. Let's see. I'm basically trying to decide whether I want to just start over. Maybe I should just start over because I think that something is fundamentally wrong here. So let's do what I was shooting for a second ago. We're going to take that part of the code out. We're also going to delete the vertices here and set it to null. Then we would go set it every frame because we will have bound this vertex array. So at this point, we can drop in the vertices. And then we will do similar to what we were doing before, where we say texture U. And I did notice that those did show up right on the screen. So in terms of the orientation, so I think we were on the right track. It's just a matter of not getting stuff exactly where it was supposed to be. Texture V plus region width. Wow. I did not want it to do that, but whatever. Don't have control over the code formatter. Damn, that really makes this not look good. Clang format, ignore region. Is there a way I can just tell it not to? Ah, fantastic. I hope this works, because that is just horrifying. Let's do this. Clang format off. Clang format on. Thank God. All right. Good to learn that right now. Okay, so we need to change the positions also. So let's say we have X, Y with height. We already have everything we need here, so let's just do that. So we're gonna do it the dumb way, then we'll fix it and do it the smart way. X plus width, Y plus height. We'll get all this lined back up again. Wasn't really expecting to be spending my time on this right now, but you know, here we are. Then it's just plain X and plain X. Okay, so now, hey Remen. All right, so on this one, it's just Y. I think I remember the way that these are laid out now. Y. Whoa, that was wrong. Yeah. Hey, Schmelly Orc. A lot more people showing up on Twitch right now. That's kind of cool. All right, so let's see. This is going to be plain old Y here. And this is going to be Y also. And this is going to be Y plus region width. Have I done matrices yet? I mean, I'm using matrices here for sure. This is plain width. All right, cool. So now for the texture coordinates, which we kind of need to line this up because it looks terrible at the moment. Let's just drop this maybe right over here. Yeah, that's good enough. All right, so this is going to be also texture U plus region width. I need some better names for these variables because this is kind of a pain in the ass to type every time. Texture V. Okay. Then the next one is also going to be texture V. And the final will be the texture V plus region width. Right about here. Okay. And then I need to update these two as well. So that one needs to be updated. Make sure we don't lose our comma. And then also this one, texture U. So in theory, this should make it easier to update everything relating to the vertices for rendering this particular instance of an image. We'll line these up a little bit also. Okay. There we are. Okay, top left. Yep. Okay, all that looks good. So now what we want to do is, well, these indices I don't need to set. I've already done that. So I've set that up, where was it? Right there. So I don't need to do that again, but I am going to set the vertex buffer for the vertices themselves. And instead of doing the 4 calls to GL buffer subdata, I can just do 1 now, which is fantastic. So we're going to do size of vertices. Is that right? Okay. And then, what was it? It's 1, right? That was the offset. Then the actual size of vertices. Oh, the offset is 0. We just need to set 0 as the offset. Okay, 0, and then the data itself, vertices. Which probably needs to be, whoops, a reference. So let's delete the rest of these. Okay. Array buffer, let's go back to this page. Offset, size, data. Okay. That seems good. Just double checking the variables that I'm using. Okay. Width, height, width, y, xy plus height. Okay. Now, I don't need to translate anymore because we've already put the x and y position into the vertex. Scaling, I probably do need to do, so scale make, but I don't need to add the width and height in because we're just going to be scaling by whatever the scale value is. So let's try this. Okay, something's not happy. Indices, vertices, 348. Oh, okay, yeah. This is going to be float times, what is it? 1, 2, 3, 4 per vertex. So 4 times 4 is 16. All right. So we're going to do float times 16 here. And that should be okay, right? What else? Indices undeclared. Did I delete that from before? Lovely. Let's go grab indices from the previous function declaration. Let's grab that. GL bind vertex array. Okay. I think that's where it needs to be. Okay, wow. Is it still the same thing? I'm doing something wrong. It just can't be right. Let's take out the scale, maybe. Kind of curious to see what's going to happen if I take out the scale. Didn't have an effect. Something very strange is happening here. Let me double check the code compilation. Something else is happening here. Come on, come on, come on. Okay, well, it didn't compile that time because everything was up to date. Something weird is happening. Wonder if I should double check the values that are coming through here. Printf, x, y, width. The texture chords seem okay-ish, so I'm not going to try to print those out at the moment. Width, height. This is going to be terrible spam, but whatever. X, Y, width, height. It'll also tell us if it's, running the code or not. Yes, something strange is happening. So this is draw texture region EX. Draw texture region EX. Draw texture region. Just gotta figure out whether it's being called or not. Then if that's not being called, what is? Okay. Did I make a mistake in this function? Yes, I sure did. That explains everything. Probably previous code could have worked correctly if I had been calling the right function. Oh, what happened there? Why did you indent it all the way over there? Yeah, that just doesn't make any sense. Will you do the same? No. Okay. Whatever. I'll deal with that later. Something weird's going on with that. All right, now maybe we'll see something different. Okay, all right. So that's some kind of progress. That's good enough to feel like something's happening. There were a little bit of red blotches on the screen. So we do have width and height more or less correct, I think. Positions look reasonable. X and Y positions. Yep. Okay, so now I don't need to write all this junk out anymore. X colon. We'll leave that in for the moment. So now that I don't have the spam, we'll run it again and just sort of examine what we see here. So there's a little bit of red on each of these, which is not what I expect to see. But it's probably a matter of some coordinates being off somehow. So in the main.msc, I'm saying that the texture X and Y is 0. Width and height is 30 and 35. So if I'm calculating things correctly, that should show up right. Oh, I'm not scaling it. I wonder if that has something to do with it too. Okay, so that didn't help at all. Let's go into renderer.c, scale. Did I do that? Okay, so printf, scale f. We're just going to see what is coming through on that. Maybe it's not a good value. Scale is 0. That's not what I wanted. And the question, oh yeah, scale 0 because I did not pass in scale x. Fantastic. Okay, so it is 4. So we don't need to translate because the coordinates are already baked in, but maybe I did make a mistake. All this time I was calling the wrong function. X plus width, X plus height. We're doing this in pixel coordinates, which means that the shader is using them in pixel coordinates. Previously I was... well, it shouldn't matter because I'm using a matrix for that. Oh, here's one problem. Big problem. Height. Height. That could explain a few things. Scale will still be wrong. Yeah, so nothing is being displayed because of that. Let me go back in here and take out scale one more time. Okay, so that is the square. It's just not scaled correctly. And also it's not centered. That's fine. The weird thing is that it's not scaling. Okay, that's fine. Okay, I understand what to do now. So inside of renderer.c, I don't want to use X here. I want to translate actually. So I still want to do the translation here through the X and Y position. I'm not going to make the scale here. I'm going to do that. And then we will say width, 0, 0, 0, 0, height. Height, 0. All right. And that should be better. Okay, so I didn't scale it yet, but what that should do is make it so that we're using transforms correctly, and maybe it won't scale wrong. Okay, good. That's better. Now we just need to center where it gets drawn so that it shows up in the right place. So to do that, we need to factor that into the translation, I believe. Yeah, so let's try, where is it? Translate make. So center, where was the centering? Center, draw centered. Plus equals, it's actually gonna be a minus equals. Height divided by 2, width divided by 2. We have center. Oh, is that why I was doing the wrong thing? What was I doing here? Yeah, I was adding. I should be subtracting to center. But yeah, that makes sense. All right, let's try this now. Nope. Let's remove it entirely and see what happens. Okay. So the corner of that tile is probably being drawn right here, but then it gets offset. Let's just try this. Oh, wait, hold on. We are using X and Y, aren't we? Yeah. Fine. Let's do this. Doesn't seem to be moving at all, does it? We're saying centered is true. Wonder if I'm passing it in right. Shader. No. Renderer.c. We're looking for centered. Printf, draw centered. D. Centered. Just to see what's in there. Yep. Okay. Should be on. Okay, so we're back to here. Yeah, that's a weird thing, is that we should be able to do the translation for that with the matrix. So this should do something. Printf centering to F. X, Y. This still should be 2.f. 2.f. There must be just something weird I'm doing about the computation. Come on now. Compilation buffer. There we go. So the flag isn't working. Subst draw centered. I guess that was never working. Interesting. Okay, so now it seems to be trying to do the calculation, but let's try this. Just out of curiosity. Take a look at the difference. Okay. All right. Before centering, so 840, 825. All right, so that does seem like it does something. Okay. Just doesn't seem to have a significant visual effect. Let's try that. Come on. That did something, but it's still not what I would expect. Something else is wrong. I wonder if the way I'm drawing the other tiles is not right somehow. And it's just not being exposed by the fact that the image for the face is not being drawn right. Out of curiosity, let's see what the other tile looks like. So 30, yeah. Yeah, so the circle is there also. A little bit aliased, I don't like that too much. Jeez. So let's think about this for a second. What is it about that calculation that's wrong? To put it in the wrong spot. We're using 0, 0. In the, you could say the model coordinates here, 0 to width, 0 to height for X and Y axes, and the texture coordinates. Texture coordinates seem to be working more or less how I'd expect them to. We're not setting the vertices first. So nothing else is happening that should be putting things in the wrong place. It'd be nice if I could draw like a rectangle around all that, but I don't have that capability at the moment. Let's skip scaling for a sec. Sorry, folks. I have no idea how long it's been on the thanks for watching screen. I think that I hit a button press weirdly. Are we still here? Anybody see me? I have to reply to a message really quick. Okay, good. Thanks, Soviet Bill. All right. Yeah, I don't know what I did. I have key bindings for controlling OBS, and apparently I hit one. All right, so we're back to trying to figure out why... Thanks, Ramen. Why this is not centering correctly. The scaling seems to be scaling the way that I would expect. But it's just it needs to be moved just slightly over that way. Okay. And even this, like I would expect it to only need half divided by 2f. Like you would only want to move over 15 pixels, but is that right? I wonder if that's not right, because we need to factor that into the translation matrix. I'm going to experiment with something really quick and see what happens. This may be wrong, but we'll see. So we're going to do another translate just to see what happens. This is probably not good. So -1 times width divided by 2.f. -1 times height divided by 2.f. I guess what I should just do is -2.f, right? If my math is more or less intact. Okay, so then I can take this out. Not really. I wonder if that has the same effect as what I was doing before. Let's see. Let me just put that there. Uncomment that. Yeah, it looks the same. So I don't know if I need to like factor the scale in somehow, which I shouldn't have to. It doesn't feel right to have to factor in the scale. We're almost there. Like the tile faces are rendering somewhat, but they're just not in the right position. So I'm hoping we can get something going real fast here. So if we try to put the XY position without centering it, let's just try it again without centering it. It seems almost the same as it was before. So maybe we do need to factor the scale in after all. How about this? This doesn't seem like it would be right. Scale X, scale Y. We would have to put this after this one. Okay, well, that worked. A little bit unsettling, but I can live with it for now. All right, so now that we've got that figured out, it's a little bit off. I don't know, like I feel like it's like 1 pixel shifted down. I don't like that, but let's see. Tile X, tile Y -1. Probably not gonna work. Oh, unexpected token kind. Yes, because I'm writing scheme now and not C. This is starting to get into black magic a little bit, but, you know. I just want it to look reasonable. Is it moving on the x-axis also? It needs a little bit of goose on that. All right, I need to think about that a little bit. So 3. That seems slightly better. But we're really splitting hairs now, I think. Okay, like, do not hard code, because this is just bad. We'll figure out the right calculations for that later, but at least we got to the point now where it's rendering more or less in the correct spot. I think it's rendering where it should be. Let's try now 30. That's the texture axis of, or a coordinate of 30. That seems more or less right. And then 60. Okay, so we have some tile faces. They are a little bit ugly, but whatever, that's fine. That was expected. Okay, so now that we have tile faces, it would be nice if we could calculate the texture XY coordinates based on the index of the tile. So I can quickly try to add that in. How about this? Texture X is now going to be the tile face for the tile, which is, well, let's see. Yeah, that's fine. The tile face for the tile. Now we need to multiply by 30. Yeah, I'm trying to decide whether we multiply by the face width, or we multiply by the number of tiles we know are in the tile, in the texture. We'll go with a number for now. How about that? Also, I think I need to add a modulo operator here. So tile face, which is an index. And we'll say that if it's 1, it should be the circle. If it's 0, it should be the square. So tile face, well, it's just the index then, right? Yes. So I need to use modulus here. Modulus of 5, or modulo. How do you pronounce that correctly? So it's the tile face index modulo 5. Or is it divided by? Which one is it? If it's 6 and you divide it by 5, it should be 1. So that's the Y, I think. So texture Y would be division. Integer division, which I don't think I'm doing reliably. We'll see exactly what this turns into. Okay, so, whoops. Nope. This one needs to be division. So modulus gives you the sort of the wrap of the value here by whatever that number is here. So this would give me values 0 to 4, depending on what index this tile face is. And then for division, it would give me the, I guess whatever the main part of the result is. So 0, 1, 2, depending on whether it's being divided by 5. So I'm basically just trying to get the XY position inside of the the graphic. And what am I multiplying this by? 30. Yeah. So 30 and 35, right? That seems right. Maybe we can print that out. Display, string, append. Do I have the latest on this? Text, X. Ooh. String append is not going to help here. I'm going to have to use display. I need a good printing function in the language. I haven't added that yet. All right, so display text X. We're going to write in here texture X. Actually, let's get that one. Put that there. Texture Y. Now let's do some spamming from mesh. Okay. Oh. Compiler error. What did I do wrong? Oh, it must be the fact that I'm using modulo when I don't have that yet. Let's see how fast we can add a new operator to the language. How about that? So we're going to go into crash slash compiler slash source slash scanner. Because first we have to add it in the set of operators. So where's plus? Okay, so here we go, %. And then in the scanner.c, we're going to go to token kind plus. And we're going to add a new entry down here for the modulo. Oops. Scanner make token, token kind %. Then inside the compiler .c, token kind plus. Come on, plus. All right, so I'm going to steal that. Put this after slash token kind %. Then modulo. So now I also need to add an op for modulo. So let's go right here. Let's put in modulo. Also need to go to the disassembler and add a disassembly line, op add. So we'll do that. Modulo. Modulo. All right, and then after we have the modulo, we need to go into the VM and add the code to execute. So op divide, we're gonna copy this. We're gonna put in modulo. Number val is number as number, and then modulo. Now let's see if this actually works because, well, let's see, what does that say? Yes, you cannot use modulo with doubles. It has to be with integers. So, it's almost like I have to cast in that case, and that's not good. Let me think about how I could do this. Maybe I can sneak it a little bit. Let's see, binary op, or I just have to hard code it to do the thing that I want. So that's actually kind of fine. Let's just do that just to make it happen fast. All right, so we're gonna, whoops, no, that's not the right place. vm.c modulo. Okay, right there. I'm gonna paste that part of the code in. Is number. Yeah. We have to just copy this code, unfortunately. And we'll take that part out. Now, I want this to be, what's it casting? Ah, okay, yeah, fine. Stack pop. Int. And then a modulo B. Whoa, what just happened? Okay, so is number as number. Sort of unrolling the macro here, as number. Okay, then a value type is going to be number val. Why are you not happy? probably is just BS. Okay. That should be fine. Now we have a modulo operator in theory. Let's see if it works. There it is. Now, I'm not using that yet, but the output that I'm getting, so text X seems right because the face is 1, so 1 times 30 is 30. Text Y, though, on the other hand, does not seem right. So let's see what's going on in main. Oh, it's probably because I need to clamp that value. It's being written out as 7, but that can't be right. Is it because I'm using 35? Let's see. Tile face tile divided by 5. That's 1 divided by 5. 1 by 5 is 0, right? Yeah. But this is a double division. So if I put 1.0 divided by 5, it's 0.2. And then 0.2 times 35 is 5 or 7. Yeah. Something like that. So there needs to be a way to truncate a double because I can't say division cast to int. That's just not going to work. All right, I'm going to... well, I was going to delete this code. Let me just take it out for right now because we know what's going on. We will also go ahead and drop these numbers in because why not? Let's just see what it looks like. It's going to be wrong. Yeah, okay, that's fine. That's the right face. Okay, so let's change a couple. 2, 3. I don't know if it's going to be visible. Let's see. Okay, so that was right. Oh, okay, we don't have a 3 yet. So, in fact, we need to change maybe that to 0, 1, 2. Okay, so, yeah, because of the X position, everything is sort of shifted incorrectly, but we'll fix that. So now, we need to add a function for truncating. And we haven't actually added a math library yet, but I think we're going to need one. So maybe we could just start adding a basic math library and just have a truncate. I don't know. What is floor? Let's see. C math.h. What does math.h call it? Because we just maybe follow the C style function names. Floor. Yeah. Double X returns the largest integer value less than or equal to X. Sounds good. I can call it floor. Floor and seal. Who knows? All right, so let's go into compiler. Source math.c. And then we're going to create a function value math floor MSC. Let me get the signature for these back into, let's see, renderer. Let me just steal one from here somewhere. Okay, we'll just drop that right there. I'll just delete everything up to the paren, join those lines, delete the trash. All right, then paste that in. All right, cool. So now I probably should also include, yikes, math.h. I don't know if that's going to cause me problems because there's actually a math.h that comes with C, obviously. Mesh. Do I want to do... No. Value. Or object. Object. Let's go with object. Okay, and I also want to grab fs. Just drop down here, steal this little bit too. Delete some of the existing things. This is the registration for the functions. So we're going to be there, I think. We're going to get this done. It's going to happen. Math floor MSC. And just call this floor. I'll probably rename this function. I'm starting to already, regret the name. So change this to mesh.math. I keep typing match. All right, and then in this, I'm going to just return number val. Oh boy. Is this gonna work? I may have to change my naming conventions. I think this is not gonna work. Okay, let's go for it. Floor of args 0, and that needs to be as number. Is that it? Yeah. Okay, so obviously to do add type check. Yeah, whatever. So that's all fine now. I also need to change this name to be math module init. I need to go to math.h, add this signature because we're going to call that function from within vm.c fs fs module. All right, cool. So we're going to say math module init math, so that we register that. We're going to go up here and then pull in math.h. And inside of math.h, we also need to steal a inclusion guard just to copy and paste a little bit. And then include vm.h, then do a little end if down here. Jackson says, what's the difference between implementing floor in a library as opposed to directly in the language? Well, I don't know how I would do it in the language because I don't have integers in the language yet. So I need to have a way to sort of pass it down. I guess I could do it, but it's better with some of these things to just do it in C functions to be faster. All right, so math module init. Let's see if it just compiles. Oh, okay. I need to go into the build.sh file, add math.h or math.c to make sure everything gets compiled in. Okay, so we haven't called the function yet. Let's go into main.msc, mesh math, and then we should be able to call floor here. And there it is. That worked. So the alignment on these seems a little off, and it's probably because I drew them that way. So I think that if I was to clean this up, I would have to go back and make sure that the alignment, everything is right. I also do not like the aliasing that's on the circles there. But all in all, I think it looks pretty good. I mean, the images are not great, but it's a starting point. We can build from there. And we have started doing basic calculation of texture offsets based on the index. So this is something I would probably bake into like a sprite library instead. I wouldn't be just trying to do this manually myself inside of my render loop, but that was good enough just to get it working for now. So I'm satisfied with the progress for today. We actually implemented sprite sheets, modulo operator, and a floor, or I guess I added a math library with a floor method all in one stream. So that's not too bad. I think it's a pretty good result. So for the next stream, what we're going to try to do is start to add actual game logic, so that, let's say, for this blue tile here and this blue tile here, we would know that both of these are playable because there's no tiles on top of them, and that's sort of like the doorway into having the ability to click on the tile and click the other to match them and then clear them from the board. So that's going to be pretty fun once we get to it. And I think that everything should be in place so that on Tuesday we can start working on that. So super exciting. And I think we're going to be like sort of, like next week is the, what is it? Let's take a little look at the handy calendar. So it's 22nd. So the following week is the week. So we have next week, and then the week after is the one where Ludum Dare is going to be on that weekend. And I'm still planning to do that. So I think we're making good progress on actually having something usable to where we could try to write a game basically in the span of the weekend there with Mesh, which would be pretty cool. You know, I started writing a language in, let's say, what was it, middle of February, and then going from 0 to having a language that I can use in a game jam in like a month. Not too bad, month and a half. Pretty proud of that. Okay, so I will, well, we got a couple minutes. Let me just try to check some of this code in. So I'll add the faces.png file. I need to add, I had to fix this too. So let me do that first. That part I need. And then, why are there empty lines here? Okay, so fix build.sh after substratic move. Then we can add faces. We can add this part of the code where we put the face inside and then change the renderer logic. That was it, right? Was there anything else in there I needed to not include? Yeah, all that stuff needs to go into. Fine, good. Makes sense. And then lastly, the render file updates. Let me just do this first. Add basic tile faces image render faces on tiles. And then we need to add the render methods here. That code needs to be cleaned up a little bit, I think. So let's take this printf out. I don't want that checked in. And then that one needs to go out too. I'm gonna have to reconcile some of this stuff later because I think this is a good approach for going forward. Module init, we moved that. That's fine. We added this function. Cool. So add what was it? Renderer draw texture region function. Let's edit that. I need to get some better commit messages going here. So CA for commit amend, renderer. How about that? Okay. And then I don't want to check this faces file in because I think it's going to be huge. Let me check that out real quick. It's actually not that bad. 4K. I could do it for now. So let's fix up on that. And then we're going to rebase the commits to reorder a little bit. I'll put it right here, move that there, commit, push it. And then also I need to check what I did in the compiler code. So I need to add math library. I don't know why I took process.h out. That doesn't make sense. Oh, I had it twice. How did that happen? Okay. Math, add initial math library. And then the stuff for the modulo operator. I don't know why that's there. Let's get rid of that change. Modulo op, disassembly, compiler.c. Let's see. Language. Add modulo operator. That works on integers. Whoops. Oh, I'm glad that happened. Why did it not like it? Reject. Oh, I need to rebase. Fine. So that gives me an opportunity to fix up this commit. And then I can pull to rebase. Where's the rebase option? There we go, R. All right, now I can push it, I think. Great. All right, so everything's committed, and all that stuff should be up on all the repos in case you wanted to go check those out. I'll put that into the show notes, and I'll check it in right after the stream is over with. But yeah, I think this was a pretty fruitful stream today. Pretty happy with what we accomplished, and keep an eye out for the stream on Tuesday where we get back into actually adding some of the game logic here that we can, you know, start clicking on these tiles and start playing it maybe, and then maybe you can actually download a build of the game and try it yourself. So we'll see about how that goes until then. Until next time, thanks so much for watching, and keep it creative. We'll see you.